Doctor,
Yes.
can you please repeat on the p value is greater than alpha?
Okay. P value greater than alpha. So do not reject HO. Okay. Do not reject HO. Okay. Do not reject HO when the probability of value of this statistic for variable x is greater than the level of significance. Okay, next, t-test is not statistically significant, and variable x has no influence. Okay. So when the probability here of t statistic is greater than alpha, don't confuse with, we compare t statistic with critical t. When absolute value of t statistic is greater than critical t, HO is rejected. But now the probability. When the probability value of t statistic for the respective variable is greater than the level of significance, so do not reject HO. Okay, do not reject HO. When we do not reject HO, what does it mean? It means that we will accept null hypothesis indicating the true coefficient is equal to 0. Okay, when the true coefficient is equal to 0, any changes in that particular variable, it won't give an impact on y. That is why we say that variable x has no influence on the dependent variable y. Okay, now let's say we discuss one example, determine whether variable I is statistically significant at 5% using p-value approach. Okay, using p-value approach. Okay, variable I. So the procedure state the hypothesis that to be tested. HO states that the true coefficient for variable I is equal to 0, and alternative hypothesis, the true coefficient for variable I not equal to 0. Okay, when it states significant, need to test whether it is significant or not significant, meaning that it is two-sided, the test. Okay, next, determine the level of significance where alpha is 5% or 0.05. 0.05. So from the estimation result, You are given the p-value. This is p-value of t statistic for variable I. Just bear in mind, in any statistical software, the probability value, the given probability value is based on two-sided t-test, two-sided test. Okay, based on two-sided test. For t test. So under decision rule, the probability value of t statistic for variable I is 0.025. And your alpha is 0.05. Which one is greater, which one is lesser? Probability value of t statistic. It is less. When it is less, HO is rejected. HO is rejected. Okay, because the probability value of t statistic for variable I. What is the value? 0.025. Is less than. Okay, is less than the level of significance 0.05. HO is rejected because the probability value of t statistic for variable n. Okay, what is the probability value? 0.025 is less than the level of significance alpha 0.05. So HO is rejected, okay, meaning that t-test is statistically significant. Okay, at 5% level of significance. And lastly, variable I has an influence on the dependent variable in this case. Okay. The dependent variable in the example is 1. So this is how we perform two-sided t-test using probability value approach. Same question. So there are three steps here in order to conduct t-test using p-value approach. First, state the hypothesis that to be tested as usual, and HO, the true coefficient of variable I is equal to 0, and alternative, the true coefficient K of variable I is not equal to 0. Then determine the level of significance. Okay, in this question it is stated 5%. So alpha percent is 5% or 0.05. Third, decision rule, and you must state the p-value of t statistic for variable I. Okay, what is the value? 0.025 and your alpha 0.05. Then you compare. Okay, it is found that to be less than. If less than, okay, the rule here HO is rejected. Okay, because p-value 0.025 is less than the level of significance alpha 0.05. Therefore, t-test is statistically significant at 5% level of significance. Variable I has an influence on the dependent variable Y. Done. Any question? Okay, next. Okay, probability value approach for one-sided t-test. Okay, one-sided t-test. Okay, we use the same example, the same question. Okay, determine whether the product is a normal good at 5%. Here, remember that the given p-values here based on two-sided. So first, state the hypothesis that to be tested. HO, H1, colon, beta, subscript I, beta subscript I. So it is positive, it is equal to 0, or I can write as like this. Okay, second, determine the level of significance okay, let's say not 5%, 1%. 1% at 1%. So alpha percent here is 1% is equivalent to 0.01. Then decision rule. Here probability value of t statistic for variable I in bracket one-sided. Here one-sided, what is the value, and alpha is 0.01. Here, probability value two-sided is 0.025. Okay, what is meant by 0.025 here? This is your probability distribution. 0.025 means because of two-sided, we have the two areas on the left and on the right. So this is 0.0125 and here 0.0125. So all together it is 0.025. So 0.025, okay, referring to two-sided. So each side here is 0.0125, meaning that if we want to find the probability value for one-sided, the two-sided probability value must be divided into two. 0.025 divided by 2, it is 0.0125. One-sided. Okay, one-sided. Our hypothesis beta is greater than 0. So only this area under H1. Under HO, negative. So we just focus to this side, only one-sided. So we compare the probability value of t statistic for variable I for one-sided. Definitely it is less than. Is it less than? It is greater than. Okay, it is greater than. When it is greater than, do not reject the null hypothesis. Okay, do not reject null hypothesis. Because p-value of t statistic for variable I is equal to 0.0125 is greater than level of significance alpha 0.05, sorry, 0.01. Is 0.01. So t-test is not statistically significant. T-test is not statistically significant. So in this case, variable I has no influence has no positive influence on the dependent variable y. So answer the question whether it is normal good or not. It is not normal good. Therefore, the product cannot be categorized as a normal good. Okay, this is how we conduct t-test using p-value based on one-sided t-test. Okay, any question?
Doctor,
Yes.
if the variable I has a positive influence, that means the
Variable
product can be
sorry. A.
The product can be categorized as a normal good.
Yeah.
Okay.
Doctor,
Yeah.
if say because this question we are to determine whether the product can be categorized as normal good. So let's say if I miss the word positive on the variable S has no influence, I miss out the word positive, that means my answer is wrong, isn't it?
Okay. Variable I has no positive influence, right? So you just mentioned variable I has no influence. Is that your question?
Yes.
Okay. Once you do not reject HO, okay, beta I is negative. So meaning that beta I has an influence on Y, but negatively related, unless if your beta I, okay, and the null hypothesis is equal to 0, then you say that it's okay if you say that variable I has no influence. Okay, but if you state your null hypothesis is less than 0, if you do not reject null hypothesis, meaning that it has an influence but negatively related. Do you get it?
Yes, doctor.
So in this case, if we specify our null hypothesis like this, if you miss the word, okay, positive here, therefore has no influence, okay, it is totally wrong. Okay, totally wrong. Unless you specify as beta I is equal to 0. So you miss the word positive, so it won't affect, okay, the continuity of your answer. Okay, it is consistent. When you accept that beta I is equal to 0, meaning that, okay, any changes in variable I would have no impact on your dependent variable. So it's okay if you, okay, miss the word positive if the null hypothesis indicating that beta I is equal to 0. If like I did, if you miss the word positive, it is wrong. Okay, question?
Okay, doctor, thank you.
Okay. So if there is no question, please alert. Okay, maybe at night I will post you a message, okay, for assignment. Is it assignment 4? 1, 2, assignment 3. Okay, I think assignment 3. Okay, please alert for assignment 3. I will give you on the hypothesis testing. Okay, hypothesis testing. T-test. And next week, we will discuss confidence interval, also t-test, and f-test. F-test plus properties of OLS and also OLS assumption. OLS assumptions. So if there is no question, it's done for the day. Okay, thank you for attending my lecture and see you next week. Assalamualaikum.
Salam dokter.
Salam doktor. Thank you.
Dokter, thank you.
Okay, welcome.